the last thing I'm going to talk about in the basics of probability is when we use the phrase at least. All right, at least one. And I talked about this earlier when we wanted at least one girl for the number of kids in a family. So at least one of my outcomes, or my event. Well, the easier way to solve that is to take 1 and subtract away the 0 outcome. 0 of my event. Right? Because it's easier to find the 0 case, the none case, than it is to find the at least 1. Because the at least 1 would mean I'm going to get 1 or 2 or 3 or whatever, however many groups there are. And so to do an example, I'm going to flip a fair coin, find the probability of getting at least 1 head. So, probability you get at least 1 head. Well, that would be 1 head, or 2 heads, or 3 heads, or 4 heads. Or 3, sorry, just 3. Only 3 fair coins are flipped. And so it's a lot easier to do the complement, what we consider the complement. 1 minus the probability that you flip no heads, which would be all come out tails. Right? That's the much easier outcome to count. If you go back and look at our set at the top, that's one of the first things that we did, the probability was 8 outcomes. There were 8 outcomes total when you flip a fair coin 3 times. There are outcomes, 8 outcomes. Right, because we have the first flip, there are 2 chances on the first, 2 chances on the second, 2 chances on the third. So 8 total. Out of the 8 total, 1 of them is the tails, tails, tails case. If you go look at the earlier set of notes, right, when I listed, actually I didn't do this, I'll do this on another page, but when you get it, there's only one outcome where you get no heads, right, the tails, tails, tails outcome. And so the probability that you get at least 1 head is 1 minus the probability of no head. So 1 minus the 1 out of 8 outcomes, right? 1 out of 8 outcomes has no heads in it, and so that means 7 out of 8 should have at least 1 head. And I'm going to go pop up another sheet of paper to sort of show this to you using the tree. Alright, so I've got my coin. I'm going to flip it 3 times. I've got my first flip, which there are 2 outcomes, and my second flip, which there are 2 outcomes, and my third flip, which there are 2 outcomes. When I multiply 2 times 2 times 2, that means there would be 8 outcomes total. Alright, I'm going to list them. And I'm going to use the tree. Alright, the tree, the first flip, it could come out heads, tails. The second flip can also come out heads, tails. And the third flip can also come out heads, tails. So again, those are all the branches. And so if you list them out, if you count, there are 8 outcomes. You get the all heads, you get the heads, heads, tails, heads, tails, tails. Oops, missed one in the middle. Heads, tails, heads. Then heads, tails, tails. And then again, that's all the ways that heads occurred first. Now the tails case. Tails, heads, heads. Tails, heads, tails. Tails, tails, heads. And then the tails, tails, tails. That's the only outcome that doesn't have an H in it, right? If you count them, those are the 7 outcomes with at least 1 heads. This is the only outcome with no heads. Alright, and so it's a little easier to figure that out and to use that. And so if you count, there would be 7 out of 8 with at least 1 heads, and then there's 1 out of 8 that doesn't have any heads, for a total of the 8 outcomes. Alright, so that's again how that one's sort of figured out. Alright, so 7 out of 8 outcomes for at least 1 head. Now we can use the short version for that. The last example, and again I'm going to pop up to kind of explain it too, but suppose this goes back to the 4 children, so we're adding a child, so we have 4 possible children. Find the probability of having at least 1 boy. Well, the probability at least one boy would be having one boy, or two boys, or three boys, or four boys. This one does go out to four. Well, the easier way to figure that out would be take 1 minus the probability of having no boys, which would mean all four come out girls. All right, girls on the first, girls on the second, girls on the third, and girls on the fourth. That's a lot easier to figure out. So if I want to know how many outcomes total, well, for the first kid, first, second, third, fourth, there are two possible outcomes. Two possibilities on the first, two for the second, two for the third, two for the fourth. And so if you multiply those out, there are 16 total outcomes. Out of the 16 total outcomes, there's only one way to get all girls. And so the probability you get at least one boy would be 1 minus the 1 out of 16 outcomes where you get all girls. And so 15 out of 16 outcomes, you get at least one boy, meaning you could have one boy or two boys or all three boys. All right, again, I'm going to go pop up sort of to show you the set using the tree like we did before. All right, so again, sort of drawing this out. So this time we're going to have more branches. So we've got our first kid, and the second kid, and the third kid, and now the fourth. So there's going to be a little bit more branches here. We know there are 16 total, because it would be 2 times 2 times 2 times 2, 4 times, 16 total. And so if I'm setting this up with branches, so I'm going to start here, I'm going to make these branches sort of small, because I'm going to go a little more. So I get boy, girl, second set, boy, girl, third kid, branches go out there, boy, girl, boy, girl, boy, girl, boy, girl, and then the fourth kid. I should give myself a little more room to start. Squeezing them in here in the bottom. My G's a 6 there. Now, if you count the end of the tree, there are 16. You count 1, 2, 3, and go all the way down. This last case is the only case without a boy. So if you look at it, this is the only outcome with no boys. All of the rest of the outcomes have a boy in it, right? There's a boy in that tree. There's just a boy in that one. Again, boy. All of these have boys because I start off with a boy. All right, that set all have a boy because I start off with a boy. That one has a set because I all start off with a boy. All right, and so there's only that last outcome where I don't have a boy. And if you count the number of tree branches, there are 16 tree branches. So that means those are the 15 that have at least one boy. Some of them have 2 boys, some of them have 3. Those at the top case has the all 3 are 4 boys. Some have 1, some have 2, some have 3, some have 4. This is the only one that doesn't. And so sometimes that's the easier way to go. It's easier to figure out there's one case out of 16 that doesn't have it. And so that's the last outcome there. So 1 out of 16, all girls. We're looking for at least one boy, which means 15 of the cases, let's take 1 away, have at least one boy in it. Alright, so that finishes up the basis of probability. We're going to basically be adding to that in the next 2 sections. Alright, so we're going to take probability, and then sort of, again, this is all about probability this week.